All right, here we are for example 8, which says this: an explosion causes debris to rise vertically with an initial velocity of 128 feet per second. The function s of t is negative 16 t squared plus 128 t. And it describes the height of the debris above the ground, s of t, in feet t seconds after the explosion. And it asks us, what is the instantaneous velocity of the debris when it hits the ground? So instantaneous velocity we know is derivative, right? So here's our key word for derivative. If you are in physics, then this should be sounding, kind of familiar. S of t, why do they use S? S is used to stand for a position function. So S of t expresses the position, the height of the debris in feet t seconds after the explosion. So something that comes up in physics, but it's kind of cool. The derivative of a position function is velocity. You learn in calculus, you'll talk about the fact that if you take the derivative of a position, think of like a height function. If you take the derivative, it gives you the velocity, which is kind of cool. And then you can take the derivative of velocity, you get acceleration. It's all kind of exciting. So we have our function s of t, which is negative 16 t squared plus 128 t. We want to know the instantaneous velocity when it hits the ground. So we're going to start by finding the derivative. So s prime of t is the limit as h goes to 0 of negative 16 times the quantity x plus h, although, all right, hold on a second. I wrote x, but really, what should I write? Think in your brain. What should I be writing? T, right? T plus h. So my formula says x plus h. However, this uses a t for time. So we'll leave it in there. All right, so I plug t plus h into my formula. Here's our, I didn't write it out this time. I was trying to save space. There's my original, right, difference quotient formula. So instead of x, I put t because t is what's actually used in the formula. So I plug t plus h in. I'm subtracting the original formula, negative 16t squared plus 128t, and I'm dividing it all by h. All right, now doing lots of algebra. I happen to love algebra. I hope that you do too. Negative 16t squared minus 32th minus 16h squared. We have our same foiling out there, right? If you need a step where you FOIL that, t squared plus 2th plus h squared, totally fine. And then we are adding in our 128t, our 128h. Now this negative is getting distributed, so we have plus 16t squared minus 128t, and that is all over h. So, whew, that's a lot going on. What cancels out? I like to color code. I was really enjoying grading some work today where you all had color coded too. That makes me happy inside. So anyway, canceling out those, what do I have left? Negative 32th minus 16h squared plus 128h, all divided by h. Negative 32t minus 16h plus 128. I am finally ready to take the limit as h goes to 0. Plugging a 0 in for that h, I get negative 32t minus 16 times 0 plus 128. So I get, for my s prime, negative 32t plus 128. And another thing I could call that is a velocity function. Pretty cool. So if you take the derivative of the position function, you get velocity. How fast is that thing traveling? What were we talking about? Debris here. How fast is the debris traveling? Now, to actually answer the question, what is the instantaneous velocity of the debris when it hits the ground? Well, when it hits the ground, and all I have to work with is time. Do I know when it hits the ground? No, in fact, I don't. So I have to figure that out. When does it hit the ground? All right, what do we know about the position, about the height when it hits the ground? I hope that you just answered. It's 0. The height is 0 when it hits the ground. So I'm going to plug a 0 into this side. I have 0 equals negative 16t squared plus 128t. We know how to solve something like that. It's a quadratic. Can I factor it? Yes, I can. Negative 16t can come out. T minus 8. I get that t is 0 and t is 8. Now this should make sense. It was on the ground originally when time was 0. And then it hit the ground again at time was 8. We're not going to use the 0 because we want to know when it hits the ground finally. So I use my 8 and I plug in. What is the velocity at 8 seconds? Negative 32, 8 plus 128. That is negative 128 feet per second. Now, why is it negative? It's negative because it went down, right? So 128 feet per second is the instantaneous velocity of that debris. Pretty cool. You can tell I like math when I talk about these problems. All right, last problem of the day, number 9, last example, I should say. A foul tip of a baseball is hit straight upward from a height of 4 feet with an initial velocity of 64 feet per second. Here is the function s of t that describes the height above the ground in feet t seconds after it was hit. The ball reaches its maximum height when the instantaneous velocity is 0. So we needed to, I'm not going to try to underline because you know I struggle with that. So putting in quotes there, instantaneous, I'm going to do it. I know I said I wasn't going to. Instantaneous velocity is 0. After how many seconds does the ball reach its maximum height? So let's do that derivative. S prime of t is the limit as h goes to 0 of negative 16. I'm going to use t again because they do t plus h squared plus 64, the quantity t plus h. I'm going to subtract my original function and divide it all by h. I would love it if you pause the video and try to work it out on your own. Here's what we get. Giving out that negative again. This feels kind of similar to the last problem, right? Stuff cancels. We have our negative 64t, our positive 64t. Our negative 16 squared are positive. We have negative 32th minus 16h squared plus 64h. We take the limit when h goes to 0. Plug in 0 for the h's. I'm sorry, I did not cancel out my h yet. Caught myself. Sorry about that. All right, I had not simplified. How did I know that I hadn't done something? Because I was going to plug in 0 and see that I got 0, and that felt wrong. So now I plug in 0. And I get that s prime is negative 32t plus 64. All right, now they gave me a hint, and they said the ball reaches its maximum height when the instantaneous velocity is 0. We have that s prime, but we could call that the velocity, right? Velocity function, negative 32t plus 64. When the velocity is 0, it reaches its maximum height, right? When something goes up before it starts coming down. So, plug in a 0. We set it equal to 0, actually. We're plugging it in for the velocity. So negative 32t plus 64. Subtract our 64 over. Divide by negative 32. And we get that the t is 2 seconds. So after 2 seconds, the ball is going to hit its maximum height. Now, that is the way I expect to see you do it if I ask you to do a problem like this, but I want to show you how this relates to something you already know. If you have your function, s of t is negative 16t squared plus 64t, we know that's a parabola, we know it's upside down. When is it going to reach its maximum height? When it's at the vertex, right? Negative b over 2a is our vertex formula. Negative 64 over 2 times negative 16 gives that same 2 seconds. Now, in this case, was that a lot faster? Yes, it was. But I really like the idea of you seeing the relationship between the two. All right, go on and do your work for 11-4 part 2. Reach out if you have questions. I hope that I've seen you on Zoom. If you're doing this before the Zoom meeting, then come meet up with me on Zoom so we can do a little practice. And I look forward to hearing from you.